Hello friends, welcomes in our today's lecture. Today we are going to start a new topic which is very important, that is Argand diagram and polar form. Argand diagram and polar form. So polar form of a complex number we have to learn, but before that, first of all we have to discuss about Argand diagram. What is Argand diagram? A name Argand. Who invents this Argand plane? Actually, we know that Cartesian coordinates, if we want to put in a system, then a system is said to be coordinate system. But if any complex number z equals to a plus ib, actually we know that a complex number z equals to a plus ib represent a point in a plane, then that point we may represent in Argand plane. So first of all, I write any complex number. A complex number z equals to a plus ib. This complex number z equals to a plus ib represents, this kind of complex number represents a point a comma b. See here, a comma b. A plus ib represent a point a comma b, and you know that this kind of point we have to plot in a Cartesian coordinate system. So this kind of all the point, or the set of all this kind of points, the set of all kinds of points, represents in a plane, is called Argand plane. Plane is called Argand plane. It means in Argand plane, again there are two different kind of axes. One is x-axis, as we know, one is y-axis. But my dear friend, here a plus ib represent a point a comma b. See here. So this a comma b, where a is known as real part of z, you know that, and b is known as imaginary part of z. So Argand derive one kind of different axis. One is x-axis, but here x-axis known as real axis, right? So a is real part of z and b is imaginary part of z. So here this a equals to real part of z and b is imaginary part of z. So this real part of z plot on real axis. Yes, he says that x-axis as real axis. So this kind of point a denotes the point on real axis, and imaginary part of z plot on y-axis, but y-axis is known as here imaginary axis. So x-axis and y-axis known as here imaginary axis and real axis. These axes are like this, as we know that. How to draw the axis? We know that two perpendicular line we have to draw. So this kind of two perpendicular line let us draw. Here this line is real axis and this line is imaginary axis, right? So this kind of two axes we have to draw. Okay, this is origin O, and you know that origin means here coordinates are 0, 0. You know very well that. Suppose I plot A here, then you know that a simple geometry, A is a, 0. This point is a, 0. See here. Similarly, let us take here any point, then this point is 0, b, and that's why this point is A is x coordinate, B is y coordinate. So this point is actually our complex number z equals to PAB. Let us take the point as P. Then this PAB representing complex number a plus ib, my friend. So a plus ib complex number represent a point, and that point we plot here or here or here or here. It means that it depends on the value of a and b. Both are positive, then first quadrant. That after negative positive, I think you know that, then in second quadrant. Quadrant to tamne khabar chhe. Both are negative, then that point will be plot on third axis. Similarly fourth axis. So third quadrant, fourth quadrant, like this. Now from origin to this distance, see here this distance o to p, this distance op is called here modulus. तो modulus આપણે previous lecture માં શીખી ગયા. What is modulus? Under root a square plus b square. Okay, this distance you may also find with help of distance formula. So here I just said that distance between o and z, that is called as modulus. Distance between o and z or o and p here. Then that is what? Under root a minus 0 square plus b minus 0 square. It means under root a square plus b square. That is called modulus of the complex number. This value is modulus of the complex number. So what is modulus? This distance OP, where OP distance is under root a square plus b square. Here distance between OP is called modulus of z, right? So modulus of z is very clear. I can write that modulus of z is under root a square plus b square now. So I think you easily understand that. Now see once again this diagram carefully. Let us take here any angle. This angle is theta. Then remember that you know cos theta and sin theta very well, right? Okay, I think you know that now this distance is under root a square plus b square. And this distance is a and this distance is b. So sorry, this distance is b, 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 and this distance is a, right? A and a. I hope you know that. So from this figure, you know that cos theta is a upon under root a square plus b square. આવડે છે ને sin theta cos theta, opposite side upon hypotenuse, adjacent side upon hypotenuse. So here cos theta can be written as, here see, cos theta is what? Adjacent upon hypotenuse. I think you know that. So cos theta is a upon under root a square plus b square, and sin theta is clearly b upon under root a square plus b square, right? Okay, this under root a square plus b square denoted as r. R is what? R is modulus. So modulus of any complex number generally denoted as small r. So therefore I can say that cos theta is a upon r and sin theta is b upon r, right? This is the value of cos theta and sin theta from the figure. Chalo, હવે બહુ interesting છે. Now a complex number can be written as, now we know that value of a is r cos theta and value of b is r sin theta. So now a complex number, I can write a complex number now. So now a complex number can be written as, now a complex number can be written as z equals to a plus ib. But what is a? A is now r cos theta plus I into bracket r sin theta, right? And therefore this z is, let us take r is common, cos theta plus I sin theta. So this is another form of a complex number. Z is equals to r into cos theta plus I sin theta. Says result number 1, which is very important result, which is polar form of a complex number. where what is r? Then we may say that r is modulus z. R is modulus z. And this theta is very important, is the angle. But this angle is known as here argument of z. You have to remember the word argument of z. But main thing is this, how can we find this argument? Here we have several results to find this argument easily. But this argument we may find with the help of a given point. So now let us discuss how to find this argument. So એના માટેની method છે. This method we have to remember as a formula. So I think now you know that every complex number represent a point. So let us see the method to find theta. Method for theta. So how can we find? I just give you a table which is not given in your textbook, so it's very helpful to you, right? We have to remember this table to find out the point. A complex number z equals to a plus ib represents a point, you know that, which is point PAB. Remember that this point PAB is in which quadrant, that is important. Suppose this point is in first quadrant. I think you know that quadrant, right? First quadrant, second quadrant, third quadrant and fourth quadrant. There are 4 different kind of quadrants are there, you know that. First, second, third and fourth quadrant. So quadrant wise we have to find out this argument of z. So theta is equals to ARGZ. ARG is the short form of argument. Now if in first quadrant, then we have to just remember, because we do not know about trigonometry very well. So in first quadrant, theta is equals to tan inverse B by A. How can we find that? We discuss later. But just remember the formula. Theta is tan inverse B by A. Because how we get this? Let us see. See the figure. What is tan theta? You can say that tan theta is B by A. See here from the figure we may just realize that tan theta is B by A. And from this we may say that, see here, tan theta is obviously B by A. And that's why what is theta? Tan inverse B by A. So that thing I just write here. You have to remember that. Here what is theta? In second quadrant this theta is pi minus tan inverse B by A. Pi minus tan inverse B by A. In third quadrant that is minus pi plus tan inverse B by A. But here I have to write that yes, tan inverse B by A. And in fourth quadrant this theta is minus tan inverse B by A. Okay, this is the thing here. Remember that these 4 results are very useful when we find out argument of the complex number. So this is the way to find out argument and modulus of the complex number. So any complex number is given, you can just find out argument and complex number, argument and modulus. So I repeat once again, what is modulus? Then modulus is under root a square plus b square, which denoted as small r. And what is argument? Argument is the angle with point to origin mixed with real axis. Real axis સાથે જે angle બનાવે, that angle is known as argument here, or as principal argument also. So with help of this theoretical results, now 2 important results we have. R modulus of z, which is under root a square plus b square. That after theta is what? Tan inverse B by A in first quadrant. Quadrant wise this theta will be changed, right? So with help of this theoretical results, we may solve all the questions related to exercise 5.2. So that we will discuss in the next lecture. But prepare this table very well. Also this polar form of the complex number. Okay. So in the next lecture now we will deal with the exercise 5.2. Thank you very much.